DFA part of this lesson. Now, there is a quite simple explanation behind why we have take this approach. So it can be easily compared against the NFA, NFA epsilon, and NFA to DFA approach. We are not going to use this. In the exam, most probably, I will say with 90% probability, you will be asked to convert a regular expression into a DFA using this method rather than that NFA and DFA route. So if you follow that route, or if nothing is mentioned, if you follow that. Okay, are you okay with the audio here, or is there any echo coming? Is it fine? Some echo is coming. Okay, what to do? Because I have to share the audio. So the video stream is actually going to use the same audio. Okay. Let me see if I can do something else. Just a second. That route you will get a 0. So please be careful. This question is most probably going to come like you will be given a regular expression and be asked to convert it into a DFA. So if nothing is mentioned, or if it is mentioned, then you use the direct DFA construction approach. You have to use this. If specifically you are asked to convert it using the NFA DFA route, then you should use that approach. So don't use that approach. That's the suggestion from my end, because otherwise you may get a big 0, even if you do it very meticulously. So, okay.
Sir, is this downloadable?
Just to get familiar with the construction process, shared the video that you don't know how it is done in the classroom. Okay.
Okay, sir.
In past, in theoretical computer science, in theory of computation class, this was not covered. So I assume that. So I'll keep the discussion to a minimum. Just keep the construction process with an example, and that's it. In the semester, you just follow it. There is a very interesting explanation behind this construction. Please look into our book why we are doing all these things. So I'm not going to give you any explanation, just the construction algorithm, which is not very, I won't say it's complicated, but it's quite elaborate. Like there are many steps involved. So we need to understand that. That's all. So from regular expression to DFA, we do one thing which is known as the important state. The important state are those states. Important states are those states which have at least one non-epsilon outgoing transition. So that means if you have a state which has no transition coming out of it, even if it is an epsilon transition, nothing is coming out of it. That means that the transition function on that particular state for any symbol, including epsilon, is the null set. Then is not the null set. Then it is an important state. If it is null, it is not an important state. In our construction process, we are going to be interested only with epsilon states. Unfortunately, only with not only with important states. Okay. So now the thing is, the way we construct the DFA or NFA, the accepting state may not have any transition out of it. So in order to make it an important state, to be sure that we have an important state as the accepting state, we append or we augment the regular expression with a special end symbol hash. So that means the accepting state becomes an important state because it has a transition on the symbol hash, not epsilon, rather symbol hash. So on the hash symbol, it will have a transition, so it becomes an important state. Now we will use the augmented regular expression R hash to construct our process. Now, what is the starting point of the construction? We'll create a construct a syntax tree. Now, this syntax tree uh, looks a little similar to what we have learned so far in compiler, but remember that this is different. I mean, although the name is same, it looks like a syntax tree, but it looks somewhat different because
স্যার একটু ইকো হচ্ছে ওর জিনিসটা
আমি দেখছি কি করা যায়
like you can see that
আমিও দেখছি একটু
in
ইকো
this
হচ্ছে
syntax tree, the leaf nodes have the symbols from the alphabet, you can say. So symbols from the sigma. Okay, so you can see that A, B, these are the two.
maybe what I can do is I can stop the audio and let the video play. Okay, so that would be the better thing. So you can see here that so from regular expression to DFA, as you can see, we are constructing the syntax tree A or B star ABB hash. Okay, that's what we agreed. Okay. So
That is the first thing. And second thing is the internal nodes can consist.
So what we can do is we can share everything. Maybe I'll just go through the documents again. So this is the, I think this is the one. Not this one. Okay, so okay, so from regular expression to DFA, as I said, we have to construct a syntax tree for R hash. R is a regular expression, and we have augmented it with the hash symbol. So what is the syntax tree? So we are trying this A or B star ABB hash. As you can see,
so this is the conversion of regular expression to DFA
directly to the optimized DFA. Okay, so here you can see there are different types of nodes. One is this guy. This is the OR node. This is the star node, means A star, B star, you know what I'm talking about. And this is the concatenation, means A and B are concatenated, means B has to follow A. The OR node means A or B can follow, any of them can follow. And star means it can
so this regular expression start A B B like
yeah,
that
this is, so I want to construct the corresponding DFA directly instead of going through the NFA and then DFA route. Okay. So as you can see, what we are doing is we are creating the syntax tree, and there are three types of nodes you can see: the star node, the concatenation node, and the OR node. Okay, these are the three types of logical connectives which are possible in regular expressions. Okay, and the corresponding symbols are what they're having is the corresponding symbols are basically the leaf nodes. As you can see, it starts with A, B, and A and B are connected via the OR node here, right here, and this is the star node to denote A or B star. Then it is concatenated with A, then it is concatenated with B, then it is concatenated with B, then it is concatenated with hash to give you the whole regular expression A or B star ABB hash. Okay. Now, it's 5 and hash gets 6. That is the last position. Okay. And
Sir,
this
what
is
is
how.
the role of L here? Significance of L?
No, it is not L. This is the OR symbol. Okay. A or B.
A or B, A star or B star, you are telling like this.
Yeah, but I'm not doing A star or B star. I'm saying A or B star. Okay. This is how I'm doing it. I mean, you can do A star or B star. That is also possible. Okay. Now, so there are 3 types of nodes: concatenation, closure, and alternation or node as the internal nodes, and the leaf nodes are all basically the alphabets from symbols from the alphabet. Okay. All right. And they all have a corresponding position number, which is unique.
Actually,
Now,
this has to be regular expression. Means
yes, yes.
the number should be regular.
Numbers are just mere numerical digits. Okay. So you consecutively number them 1, 2, 3, 4, 5, 6 like this. Okay. The positions they can occur. Like the first A can occur at position 1. The first B can occur at position 2, like this. Okay. It can actually occur at position 1. We'll talk about that. Okay. But we are giving them a sequential numbering. All right.
Yes, sir.
Then what we do is we construct a few things known as nullable, first pause, last pause, and follow pause. Okay. So let us look at the definition of these. Nullable means whether the language generated by the node n can contain an empty string epsilon or not. Okay. Like for example, A star. Is A star a nullable or not? Can you tell me? Yes, Pranay?
Yes, sir, nullable, sir. Because
Yes.
I can consider epsilon also, sir.
Absolutely. So this is a nullable one. But just A is not nullable. A
No,
plus
sir.
is not nullable. Okay. A question is also nullable. So this is how we define as nullable. So
Sir,
this
A
is how
plus B whole star can be nullable.
yes, of course, because you can have the epsilon there. So if the node is so look at the leftmost column here. Node n, if the leaf is epsilon, then it is nullable. If leaf is I, it is not nullable. Okay, like if leaf is A, it is not nullable, right? But if you have C1 or C2, this is what it is: C1 or C2. So this is nullable. How can it be nullable? If C1 is nullable or C2 is nullable, then the whole thing is nullable. Similarly, C1 and C2, right here, right here. So if C1 is nullable and C2 is nullable, then this is nullable, right? Am I clear? Am I clear? In this column,
Yes, sir.
yes. C star, as you can see, it is true. So it can be nullable. Now, for leaf I, it cannot be nullable. For C1 or C2, it can be nullable only if C1 or C2 is nullable. Any of them is nullable. In case of concatenation node, if both are nullable, then only it is nullable. In case of star node, it is nullable. So it is true. Now, the definition of first pose is set of positions under n that can match the first symbol of a string in Ln. Okay. So let us see an example of that. So as you can see, if it is a leaf epsilon, so if your leaf is like epsilon, so it cannot match any position because epsilon cannot occur in any position. Forget about first or last. So it is the null set. Okay. But if your leaf is say A and it has a position number say 3, then this node 3, this node number 3, the first position is 3 only, because the definition of first pose is set of positions under n that can match the first symbol of a string in n. So if your node consists of only a symbol which can occur at position 3, so its first position is 3. Okay, so that's what it is. Similarly, last position definition is the set of positions under n that can match the last symbol of a string in ln. ln is the language generated by the node n. So in this case, for a, first position is 3 and last position is also 3, because it is a single symbol.
Sir, but here if it is first, C1 is nullable, but C2 is not
I'll
nullable.
come to that. No, I'm come to that. I haven't come to C1 or C2. I'm just at leaf I. So leaf I, first position is a set consisting only of I, and last position is also a single element I in the set. Okay, is this agreed? Like,
Yes,
right?
sir.
Yeah. Okay, fine. Now, question about how can you do for A or B? Okay. So for A or B, as you can see, so suppose you have A or B like this. A has a position 3, B has a position say 4. So this is the thing. So we have an OR node, and here we have A and we have B. Okay. Say suppose A has a position say 3 and B has a position say 5, first position. So any string under A can occur, the first symbol can occur at position 3, and for B it can occur at position 5. So for this node, what can you say about the first position? This is A or B. So what is the first position? Any of the string generated by this node can occur. What is the first position it can occur? Of course, it can occur at 3, right? Because A can occur at 3. So this OR string can have an A, and the first position is basically 3. But B can also occur at the first position. So the first position, a string generated under this node, can be 5. Okay, so both are possible. So that means if you have the OR node, the first position under this node is a union of first position C1 and first position C2, because C1 can also occur first or C2 can also occur first. So their first position can be included in the set. A union of their
Sir,
first
what?
position. Yeah.
Sir, what 3 or 5 denoting? You denoted with 3 or 5.
3 is the first position where A can occur, and 5 is the first position where B can occur.
Sir, you are selecting it randomly, though.
Right. I'm just giving an example.
Okay, sir.
Yeah. So then the OR node has a first position which is can be 3 or 5. Similarly, for last position, it can be 3 or 5, which is a last position of this guy and last position of this guy, a union of that. So in case of a OR node, it is always a union symbol, because it can get the values from either C1 or C2. In case of C1 dot C2, can you tell me what is the speciality? So you have C1 here. This is the concatenation node, and you have C2 here. What is the first position?
Sir, C1, C2.
No, that is not correct. You can say it is first position of C1.
Yes, C1 first position is fixed, and C2 will always come in last. If we
No, that is not correct. It will be definitely first position of C1, and you can say first position of C2 provided
But both will combine and come, sir.
no, if C1 is null, if nullable C1, right? This I can say, because if C is nullable, then the string will start with C2. So this is the thing. If nullable C1, then first position C1 union first position C2. So if C1 is nullable, then first position of C1 has to be there and first position C2 also has to be there. But if C1 is not nullable, you cannot have the first position of C2 coming. So it will be always first position of C1. Okay.
Sir, means the string will be like that. Sir, C1 or C2 or C1 C2 or C1 C2 C1 C2, like this it will be happening.
Yeah, I'll come to that. Just a second. Yeah. Like, for example,
Sir, we can have epsilon also.
হ্যাঁ বলো হ্যাঁ বুঝিয়ে দিচ্ছি হ্যাঁ ধরো suppose A can, okay, if it is a single symbol, say A, and what is the first position A can occur? It depends on its positional value. Suppose A has a positional value 3. What is the positional value? I have already talked about that. This is the positional value. You have seen, we have given some positional values, position numbers, all the leaves. Okay. Suppose you take the A which occurs at position 3. So if I just focus on this, okay, so this node which has only a single number attached to it, what is the first position this A can occur? Only at 3, right? It cannot occur before that, right? Okay. Similarly, when can A occur at the last position? What is the position it can have at the last? It can also occur at the last position as 3, because that is the only number it can attach itself. Am I clear?
Sir, means you are saying that A will be alone.
If A is alone, this A is alone. Okay.
Yes.
It can occur.
It can start as first position as well as last position.
Yeah. So it will be having only one value, which is 3. But look at the node, this guy, OR. So you can see that OR has left child as A and right child as B. A can occur at first position as 1 and B can occur at the first position as 2, right?
Yes, sir.
So what about this node? This node can generate the language A or B. So it can get first position from A, which is 1, and it can get first position from B, because B can also occur at the first position. In that case, the first position it can occur is at 2, right?
Yes, sir.
Because that is the positional value it has. Am I clear?
Yes, sir. Sir, but if both occur, then sir, B is fixed for the last position.
Yeah, if both occurs, I'll come to that. Okay, Devdeep, did it clarify your point a little bit? Okay, basically, look at the definition of first pose. First pose means set of positions under n that can match the first symbol of a string in ln. So ln, so if you have A or B, what is the language generated? Language generated is either A or B. A can occur at the position 1, B can at the occur position 2. So the set is 1, 2. Am I clear? Am I clear? But now if you have, say, A or B star, then it's a different thing, because now you can have A, you can have B, now you can have A, I can have B, like this. Okay. So then also you can define the first position and last position. I'm coming to that. Okay. But if you have A, B, this is the string, then what is the first position? The language generated is AB. So what is the first position possible? Only the first position of A, right? Which is 1 in. But if A is nullable, then this first position can also come. Okay, A is not nullable in this case, but we can have a language which is C1, C2, and C1 can be nullable. Though then the first position of C2 will be also in the set. Am I clear? Am I clear? Yeah. Okay, that's the point. It's not a big deal. That's what exactly we have done in calculating the first I'll follow. It's very similar to that. Who came? I can't see anybody who joined. Okay, so first position of C1 or C2 and first position of C1, C2, both are defined here. Now, what about the last position of C1, C2? Again, is the same thing. Last position of C1, U1, union last position of C2, because any one of C1 and C2 can occur in the language generated by C1 or C2. In case of C1, C2, look at this. This is interesting. Sorry. If you have C1, C2, so what is the language generated? It is the language generated is C1, C2. But if
Yes, sir.
C1 is null, it can generate C2 as well,
Yes, sir.
provided C1 can generate null.
But
Okay.
sir, C2, C1 will be not there.
No, C2, C1 will not be there.
Yes,
Also, it can generate C1 provided C2 is null. These are the three
I can
possibilities.
say that if C1 and C2 is both are not null, so in combined C1, C2 will always occur.
Absolutely. This means C1, C2 does not generate null. Right? So these are the three possible combinations. Okay. This is the condition, and this is the condition for second thing, and this is the condition for third thing. Okay. So either C1, C2 or C2 or C1. These are the three possibilities. So if we are calculating the first pause, here only C1 will be valid. Here C2 can be valid. Fine. In case of last pause, let's see what about last pause. Last pause means here only the last pause of C2 is important. Okay, but here last pause on C1 is also important. So if C2 is nullable, then last pause of C1 and union last pause of C2. But if C2 is not nullable, then last pause of C2 is enough. And that is what is meant here. You can see here, if nullable C2, then last position of C1, C2 is last position of C1 union last position of C2. If C2 is not nullable, then we have to get only the last position of C2. All right. Similarly, for C1 or C2, C1 or C2 is basically last position of C1 as well as last position of C2. Now, what about star node? Look at the star node. Star node, it is always first position of C1 and last position of C1. That's it. Because C1 can be followed by itself. So C1 can occur at the beginning, C1 can occur at the end, like this. Okay. Okay. So now we have calculated the syntax tree with annotation of the first pause and last pause. And this is the values it will get. As you can see, A has 1 and 1, B has 2 and 2, the OR node has 1, 2, star node has 1, 2. Now, this is important, this node right here. So, this node has this guy as the left child and this guy as the right child. So, this is C1 and this is C2. So, let us focus on that. Let us write down this. So, we have this, and we have this. And what are the values? This guy has values 3 for first position, and for last position it has the value 3. And this star node has 1, 2, and here also 1, 2. First position is 1, 2, last position is 1, 2. So what is the first position of this guy? The concatenation node. This is C1 and this is C2. Can you tell me what is the first position right here? This is C1, this is nullable, and C2 is not nullable. So can you tell me what is the first position of this OR node, this AND node? So this AND node has a left child C1 whose first pose is 1 and 2. But it is nullable. So A also, right child can also occur as first position. So 1, 2 will come from C1 and the 3 will come from A. So it will have the first position as 1, 2, 3. Nullable C1 তো থাকবেই, C1 can have occur. Nullable doesn't mean C1 cannot occur. C1 can occur. And then C2 also can occur if C1 does not occur. That possibility is there. But what is the last position of this AND node? See, C2 is not nullable. So C2 always has to occur. So that means it will be just 3. Right? C1 can never occur at the end. So the last position of C1 is not important. Okay. This is how you calculate it. Okay, you can see 1, 2, 3 and 3 here, right here. Similarly, 1, 2, 3 and 4. Similarly, 1, 2, 3 and 5. And similarly, 1, 2, 3 and 6. That's it. So you constructed the syntax tree with position values annotated. Okay. Now we need to define an important function known as follow pause. What is follow pause? Set of positions that can follow position I in any generated string. This is important. The set of positions that can follow position I in any generated string. So what does it mean? So if you have C1, C2, then you can be sure, okay, the definition says set of positions that can follow position I in any generated string. Okay. So here you can say that if C1 has last position say 3 and C2 has a first position say 5, then what can you say? Something in C1 can occur and then it can be followed by something in C2. So what is that something? It can occur at position 3 and then it can be followed by 5, right? Am I clear? Right? Are you with me? So if C1, C2 is like this, anything in C2 anything which occurs as the first symbol in C2 can be followed by the last symbol in C1. So that means anything in first position of C2 is following the last position of C1, anything in C1. So that means for all I which are in last position C1, will be followed by first position of C2. Please note that. So what I'm saying here is if you have a string like this C1, C2, then if I is in last position C1, then follow pause of I should be having as a member
C2. C2 থাকবে তো ফল পজে
first pause of C2. Thick, right. So all first position of C2 should be in follow position of I, where the I belongs to the last position of C1. This is important.
স্যার এই ফলো পজিশনটা কি যেমন আমি এতে ওই পার্সারের যে ফলো ওই ফলোর সঙ্গে
একদম ওই ধরনেরই ব্যাপার, ঠিক আছে? এক্ষুনি আমরা দেখবো যে ডিএফএ এনএফএ তে এটা কিভাবে অ্যানালগাস হয়, ঠিক আছে? নাও উই ক্যান সে দ্য সেম থিং অ্যাবাউট C1 স্টার। C1 স্টারের ক্ষেত্রে আমরা কি বলতে পারি? এনিথিং হুইচ ইজ ইন লাস্ট পজিশন অফ C1 for all I belonging to last of C1 follow position of I should include as a member first of what? First of okay, C1 star you can say it is C1 C1 like this. So C1 is always followed by C1, so it will have first position of C1. These are the only two rules. Okay, so you cannot say anything about C1 or C2. Why? Because you don't know which one will occur first and which one will occur second. You cannot say it will be C1 C2. It may not occur. It may be only C1 or only C2. In fact, it will never be C1 C2. So you cannot say anything. Okay, so only for concatenation node and star node you have this algorithm. For each I in last position C1, follow position I should be having follow position I union first position of C2. That means everything in first position of C2 should be in follow position of I. Similarly, for star node, anything in first position of N should be in last position of N as well. That's it, nothing else. All right. So if we have this, can you tell me what would be the follow position of node 1? Node 1 means this A. So where does 1 occur? What are the things 1 occur? As you can see, 1 occurs in this star node, 1 occurs in this concatenation node, all these concatenation nodes. Okay. Okay, so let's look at N, which is this guy, say 1 2 3. So what can we say about the node 1? Which number can follow 1? Can you tell me? Where can we see this? So we can actually start from the start node. Star node, as you can see, its first position is 1, 2, its last position is 1, 2. Okay. So 1 is right here. So this one can be followed by what numbers? Remember that C1 star. So C1 star, last position of C1 contains 1. Okay. And it can be followed by any of the first position of C1 as well. So both 1 and 2 are in the first position of this star node. So 1 can be followed by 1 can be followed by 2 as well. So that's why you can see for node 1, 1 and 2 is in follow position of 1. Fine? Am I clear? Am I clear? Am I clear? What about 2? Same thing, from this star node, you can see 2 is in a last position of star, and the corresponding first positions are 1 and 2. So 2 can be followed by 1 and 2 can be followed by 2 as well. So you can see for 2 as well, 1 and 2 occur in the follow position. Very good. Now let us look into this concatenation node. This concatenation node. What does this concatenation node have? This concatenation node have last position as 3 and first position as 3. What is the first position of this concatenation node? 1, 2 and 3. Okay. So what I can say that, so what is the rule? For C1, C2, the rule says that anything in the last position of C1 should be followed by a first position of C2. So what is C1 having? C1 is having 1, 2 and 3. So let's take 1. 1 can be followed by the first position of C2. What is that? 3. So 1 should be followed by 3 as well. Okay. Similarly for 2, since C1 has first position as 1 and C1 has a last position as no, I'm sorry. Yeah, C1 has a last position 2, right here. So C1 can have a last position 2 and C2 has a first position 3. So 2 can be followed by 3. So that's why you see for 2, we have the value 3 in follow position of 2. Am I clear? Okay. Is it clear? 1 and 2, corresponding entries for 1 and 2 are clear, right? Right?
Yes, sir, clear.
Okay. What about for node 3? So node 3 has to occur in the last position of C1 and it has to be followed by a first position of C2. Where can we find such a node?
Sir, this table is not clear.
Yeah. This table is clear, right? Okay, fine. So,
No, sir, this table, sir, this table in 3 is not clear.
okay, 3 is not clear. So for 3, we need to find out a C1, C2, where C1 has a last position 3 and some value of first position of C2. Where can we find that? Okay, if you look at this node right here, this star node, the left value is C1 and here you can see the last position is 3 and the first position here is 4. So this is 4. So that's why 3 is followed by a 4. That means follow position of 3 is 4. Similarly for this node, the left child C1 has last position as 4 and the right child B has first position 5. So 4 is followed by 5. Similarly for this guy, 5 is followed by 6. For 6, nothing is following it. So it is null. It is a
Sir,
null.
I can say that follower 5 is 6.
Follower 5 is 6 because of this node. Left child, last position 5. Right child, first position 6. So 6 follows 5. Okay. Am I clear?
Yes, sir.
So this is the rule for creating the follow pause set. Now,
Sir,
what?
here, sir, there the follower 6 will be first of 5.
Follow of?
6 will be first of 5.
No. Follow of 6, there is nothing. 6 is not followed by anything. That's why you have the null stream.
Okay, sir.
Okay, so now we have this table. Now, if you create a diagram to show the follow pause, like for node 1, you create an edge to all the values. So you create the nodes first, like 6 nodes, 1, 2, 3, 4, 5, 6. Now you add an edge between a node and another node if the second node follows the first node. Like for example, for the node 1, you can see the follow pause contains 1, 2, 3. So there is a loop here, there is an edge here, and there is an edge here. Similarly for 2, similarly for 3, there is only an edge to 4. For 4, there is an edge to 5, and 5, there is an edge to 6. This is nothing but your NFA minus epsilon. So NFA without epsilon corresponding to your original regular expression A or B star A B B hash. This is the corresponding NFA. I don't know the proof anyway, but I'm not going to prove it here anyway. But you take my word for it that this is the NFA epsilon you can create if you just create the diagram out of this follow pause. Okay, just give me 1 second. জানলা বন্ধ করে দিতে পারো, ঠান্ডা আছে। হ্যাঁ, ওকে, না হয় সব করে দিয়েছো, ঠিক আছে, থ্যাঙ্কস। Okay, all right. So as you can see right here on page 11, we have got the NFA minus epsilon. Okay, now comes the important task of creating the DFA. We are not going to convert the NFA to DFA. Rather, we are going to use this algorithm. What is this algorithm? Very easy. So what is the root of the syntax tree? What is the root of the syntax tree? This guy. This one. Okay, right here. Now the algorithm says S0 is the first position of root, where root is the root of the syntax tree for R hash. So what is the first position of root? Can you tell me what is the first position of root? Yes? Yes? The root is right here. What is the first position of root? Yes? That is the root of this particular regular expression, syntax tree created out of the regular expression. What is the root? And what is the first position of this root? Right here. 1, 2, 3. Okay. So the algorithm says your starting state S0 is a state which contains the first position of root. And then you create the DFA states. You start populating the DFA starting with this S0. Okay. So here our starting state would be what? Our starting state would be 1, 2, 3. This is the starting state of the DFA. Fine. This is S0. We mark it as S0. Okay. Look at the second algorithm. Okay. While there is an unmarked state T in these states, mark it. So we mark it. Then for each input symbol A belonging to the alphabet, let U be the union of follow position P for all positions P in T such that the symbol at position P is A. So we have the symbols A and B here. We have the symbols A and B here. Okay. So A can occur at this position, and what are the other positions? A can occur at this position as well. So the corresponding position indexes for A are 1 and 3. Okay, 1 and 3. So the algorithm says for each input symbol A, so in this case for A and B. So if we start from A, for all positions P in T such that the symbol at position P is A, that means 1 and 3. That means for A, it is 1 and 3. For B, it is 2. This is for A and this is for B. So for A, 1 and 3 are the positions. Let U be the union of follow position P. So follow position of P means follow position of 1 and 3. So we need to compute.
The follow position of 1 and 3.
Absolutely. 1 union follow of 3. So what is follow of 1? What is follow of 1? Follow of 1 is 1, 2, 3, and follow of 3 is 4.
4, yes, sir.
So this is 1, 2, 3, 4. Okay. Let's see what the algorithm says. Algorithm says U with the union. If U is not empty and not in these states, then add U as an unmarked state to these states. Fine. We'll add that. So we'll add 1, 2, 3, 4, 4 here. So 1, 2, 3, 4 is added in the DFA like this. Okay, and it is not marked. Don't mark it. Then we have to do the same for B as well. So for B, the only positional value is 2. What is follow position of 2? Follow position of 2, as you can see, is 1, 2, 3. So no new states are created. We have already created a state which is marked also. Okay. So now, once we have done for both A and B, since these are the only two symbols possible in the alphabet, we have to create the transitions from this state T right here to U, which are the new states or the old states. So that means for here we'll create this and we'll mark it as A, and here we'll do the same and we'll mark it as yes,
Sir?
B, because this transition is happening on B.
Yes, sir.
Right. Okay. Because this is basically the follow position of B. Okay. Now this is not marked. So let's start with this. Mark it first. The algorithm is very simple now. So now here we have 1 and 3 for A. This is for A. And 2 and 4 for B. This is B. So for 1 and 3, we will continue to be in this state only. So for 1 and 3, for A, we will be continuing in this state. So we will be here, right here. For 2 and 4, follow position of 2 is 1, 2, 3. Follow position of 4 is 5. So we need to create a new state, which is 1, 2, 3, 5. Right here. So this is another new state. And we have to put the transition on B. Then we start with this state. Okay, again 1 and 3 are A and 2 and 5 are B. So for 1 and 3, it will go to 1, 2, 3, 4. So this is the transition on A. And for 2 and 5, for 2 it will be 1, 2, 3. For 5 it is 6. So we get a new state 1, 2, 3, 6. And we put a transition on B right here. So once we are done with 1, 2, 3, 5, let's focus on 1, 2, 3, 6. For 1 and 3, which are A, it will be 1, 2, 3, 4 again. So we mark it like this. And this is our A. Okay, for B, we have only 2. So 2 is followed by 1, 2, 3. So we mark a transition from here to this guy. Of course, we mark it.
Sir, if you explain it once again, sir, I can বুঝতে পারিনি ওই part.
কোন জায়গাটা বলো, কোন জায়গাটা বুঝতে পারোনি বলো।
এই স্যার আপনি যখন এর মানে এর উপর সেলফ লুপ দিলেন ওইখান থেকে একটু ডাউট হচ্ছিল।
আচ্ছা দেখো, লেটস টেক দ্য স্টেট 1, 2, 3, 4, ঠিক আছে? এই 1, 2, 3, 4 এর মধ্যে 1 corresponds to the position of A, 3 corresponds to position of A also, right?
Yes, sir.
And 2 corresponds to position of B, and 4 also corresponds to position of B, তাই না?
Yes, sir.
এটা 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 বুঝেছো তো?
হ্যাঁ স্যার, মানে এবি এবি একসঙ্গে হচ্ছে আর কি এটা স্ট্রিংটা।
হ্যাঁ, এবার তাহলে কি 1 এর ফলো পজিশন হচ্ছে 1, 2, 3, 3 এর ফলো পজিশন হচ্ছে 4। তাহলে for A, the symbol A, the follow position can be 1, 2, 3, 4, which is the same state. So that's why you have the self loop. Okay. Am I clear?
স্যার 1 এর ফলো পজিশন 2 আর 3।
1 এর ফলো পজিশন হচ্ছে 1, 2, 3, দেখো
1, 2, 3,
1, 2, 3, আর 3 এর ফলো পজিশন হচ্ছে 4। বুঝতে পেরেছো?
হ্যাঁ,
সেই জন্য আমি ওটা করেছি।
স্যার মানে আমরা যখন পার্সার পড়ছিলাম তখন আপনি সেই ফলো করাচ্ছিলেন ওই কনসেপ্টই তো নাকি ফলো না একটু আলাদা?
ঠিক নয়, এটা মেইনলি হচ্ছে যে তোমার ট্রানজিশন ডায়াগ্রামে কোন সিম্বল কাকে ফলো করতে পারে, ঠিক আছে? কারণ আমরা তো ট্রানজিশন ডায়াগ্রামটা তৈরি করার চেষ্টা করছি, অলরাইট? ঠিক আছে, এই হচ্ছে কনস্ট্রাকশন প্রসেস। সো when you add the last symbol 1, 2, 3, 6, last state 1, 2, 3, 6, for A we have the transition to 1, 2, 3, 4 state, and for B we are transitioning to the 1, 2, 3 state. Okay. Now interesting thing occurs for 6, this guy. This corresponds to the symbol hash. This is final. That means if a state contains the hash contains a position corresponding to hash symbol, that means it is a final state. So we mark it as final as well. So that's it. So we have constructed the DFA corresponding to this regular expression A or B star ABB. That's it. We just added hash to include the final state so that we have an important state to terminate our DFA, means get the final state as an important state. Otherwise, that final state will not come. Okay. Am I clear?
Yes, sir. Sir, in this, sir, ABB cannot come.
No, ABB can come. ABB can come. Look at that. First
Sir,
A.
but it is A and B is combined, so it is violating. No?
A and B combined. Where do you see that?
Sir, actually, first position is fixed for A, I think.
No.
That-
Yeah, first position is fixed for A. Yes. Okay.
oh, B can happen.
Yeah.
A, B,
You
okay.
give me a string, I'll show you how it works. You give me any string in this regular which is generated out of this regular expression, it is going to be accepted by this DFA. You can
Okay,
try
sir.
any string. It has to be because it's the construction process. Am I clear?
Yes, sir.
Okay, that's about it for the direct DFA. There is a lot of theory behind it, I guess. I have never really studied because I am not an expert in automata. So whoever has taken your automata class, is it ACSR or is
And
SC?
yes, sir.
Maybe you can bug him. Okay, I don't want to. Okay, maybe I'll tell him just jokingly. I guess he's very busy with some other classes. But yes, I don't think you had this construction in your automata class, right?
No, sir.
Yeah. But remember one thing, if you do it the other way around, means using NFA and DFA, you will get 0. You have to probably do it this way, unless specifically instructed to do it that way. If there is nothing said, you will do this way. And to be on the safe side, because who knows, Shilpi madam and others who are tough examiners, if they check it, maybe you should do both.
Okay,
Okay.
sir.
I have seen in past, nothing was mentioned. So some teacher actually gave 50% marks if you did this way or that way. So somebody who did both ways, they got full marks. Okay. So to be on the safe side.